Hey everyone. So today we are going to be doing our practice problem for the scientific method. So last week we learned a whole bunch of new information all about planning and preparing to actually do an experiment. So we learned about the scientific method, kind of the steps that lead up to the scientific method, all of the vocabulary words, and kind of the planning portion before you can actually do the experiment. And now today we're going to be putting those into action and kind of seeing how that would work in an example in a practice problem. So today we have a few different parts of what we're doing. One, we're going to go through this slideshow and kind of do a practice problem together. But you're also going to be using, and I'll show you, this document here. So it is the scientific method practice problem. Basically, what will happen is I'm going to go through our slideshow, and then at certain times, I'm going to pause and I'm going to ask you to fill in on this sheet, on this document, what you think the hypothesis is, what you think the experimental group is, what you think the control group is, what you think the independent variable is, dependent variable, constants, etc. So don't just fill this out willy-nilly. Like throughout the video, I'm going to ask you to pause and then tell me what the hypothesis is. So by the end of today, you will need to have turned in this document. So you need to work on this document and use the video to help you, okay? So hopefully that will be clear. All right, so let's get into it. So we are starting with our practice problem. And basically, with these types of practice problems, we're going to give you a scenario that is a potential experiment, and we'll go through each part of planning for that experiment. So here is our setup, or our scenario. It says you want to determine the effects of a certain fertilizer on the growth of orchids grown in a greenhouse. So an orchid is just a type of flower. I'll show you what it looks like. They are these like pretty ones. Typically you see them at like Acme or like grocery stores in these little pots, and then they have little clips, and then they have all the flowers on the ends. These are my favorite ones. I love them. They're so pretty. So that's just what an orchid is, okay? Just a type of flower. So back to the scenario. So we're going to be planting orchids in a greenhouse. Great, lovely. Materials that are available for us to use are a greenhouse, 100 orchid plants, water, fertilizer, and soil. We want to know if the orchids will grow best with a weak concentration of fertilizer or a small amount of fertilizer, a medium concentration of fertilizer or a medium amount of fertilizer, or a high concentration of fertilizer, which would be a lot of fertilizer. This word concentration refers to a mixture between, typically it's something and water. So if you think about juice, sometimes you'll see like 100% juice or juice from concentrate. Basically, a concentration is like a stronger solution that has all the water taken out. So if it's a weak concentration, that means that there's not a lot of fertilizer in the water fertilizer mixture. If it's a medium concentration of fertilizer, it's more so than weak, but medium, and then high is a lot. So how will we design an experiment to test different concentrations of this fertilizer? Okay, so let's see. We are going to first think about our hypothesis. So we already kind of went over the other parts. We've asked the question, which is, I wonder if our fertilizer will help the orchids grow. Let's see. We did some research and we found out what types of fertilizer we're going to use. Great. Now we are going to come up with our hypothesis, what we think is going to happen, an educated guess. Okay, so the biggest thing when we are writing our hypothesis is that we want to use the if-then format. So I'm actually going to give you a little bit of a starting point. So on your sheet, remember you should be kind of using this as well. You want to say something like this: if I give orchids a small amount of fertilizer, a medium amount of fertilizer, and a large amount of fertilizer. Then this is where you come up with your actual prediction, okay? Basically, for these hypotheses, you really want to focus on if I do this, meaning what are you going to do in the experiment? And basically, the basis of this experiment is giving different amounts of fertilizer to orchids. So I really want to spell that out after the if. If I give, and I'm not just saying if I give orchids different amounts of fertilizer, I'm saying what exact amounts I'm using. If I give orchids a small amount, a medium amount, and a large amount, then pretty much you would fill in the blank. You would say, then the whatever amount of fertilizer, will grow. And let's see if we go back to this. It says we want to determine the effects of fertilizer. So we want to know, how will it grow best? Well, how would I measure growth? How would I know if it grew the best? Well, I would probably be able to think of, okay, then the blank amount of fertilizer will grow. I could say best, but if you think about what I'm actually going to do to measure how well it grew, you can kind of think like, all right, well, chances are if I'm measuring growth, I'm going to use height. So I can say we'll grow the tallest, or we'll grow the most in height, something like that is good. So pretty much I gave you the hypothesis. You just need to think in your mind what amount will be the best, okay? Which one will grow the tallest? So what you can do is, we'll grow taller. That's bizarre. It should be tallest because there's 3 options. So you can fill this in. What you should do is pause the video now, go to your version of this document, and then fill in, type out, if I give orchids a small amount of fertilizer, you have to type this entire thing. When I go to look at your document, I don't want to see for hypothesis, medium amount. No, type this entire sentence, okay? So I'll leave it at this. You should pause it now, type it in. Okay, we're back. So you should have typed in this entire sentence, and you should have also filled this in as well with whatever you think it's going to be, okay? So a possible hypothesis, we'll go back to this slideshow. A possible hypothesis could be, if I give groups of orchids a low concentration or a small amount, a medium concentration or a medium amount, and a high concentration of fertilizer or a large amount, then the orchids given the medium concentration of fertilizer will grow best. Ta-da! There we go. Okay? So that is the case with our hypothesis. Okay? Next up, we are going to start planning the setup of our experiment. So that's when we determine the independent variable, the dependent variable, the control group, the experimental group, etc. So this is a suggestion of how the plants could be divided into groups. Okay, so this person who's actually doing this experiment is going to set it up like this. Group A is only going to be given water, no fertilizer, and obviously this is the beginning, so we don't know how much it has grown. But group A is only getting water. Group B is going to be getting weak fertilizer, or a small amount. Group C is getting medium fertilizer, or a medium amount. And group D is getting a high concentration of fertilizer, or a large amount. Okay? So at this point, we want to determine what the experimental groups are going to be. What the experimental groups as well as the control groups. So what I'd like you to do is go back to your document. You are going to say, is group A, B, C, or D, the experimental group? And remember, for a control group, you're only going to have one. Is it going to be A, B, C, or D? Which one do you think is going to be your experimental group or groups? There's a hint. There's probably more than one experimental groups. And then which one do you think will be your control group? I'll go back over here. We'll present. So at this point, you should be pausing the video and then filling in that document. What you think will be, what groups will it be, A, B, C, or D, that are going to be experimental versus the one control group. Okay, so pause it now. Okay, and we're back. So you should have filled out that little document describing which group is experimental versus control. So we are going to see what the experimental groups are. Whoa, this is a funky setup. Let me fix it so we're not all cramped up. That's what happens when it's bolded. So weird. Okay. Yeah, we don't need to be bolded. All right, so for our control group, remember, this is what's going to be normal. So how plants would normally grow in nature. And think about it, there isn't like, a little person who walks around the forest fertilizing all of the plants. So our control group, what would normally happen is the plants that are receiving just water, okay? In nature, there's no one coming around with Miracle-Gro and sprinkling it on all the plants. So that's our control group. The experimental group, we actually have more than just one. The experimental group is going to be the plants that are receiving water and some amount of fertilizer. So if we go back to the table, group A is our control. Groups B, C, and D are the experimental groups. Okay, so that's what you should have on your practice document. Okay, so we have group A, groups B, C, and D. Okay, so now we have our independent and dependent variables. Again, we want to be thinking of, for our independent variable, what is the scientist changing in this experiment? What are they setting out? And they're saying, ooh, okay, well, if this is my experimental groups, this is the thing that I'm going to be changing for each of these. Versus our dependent variable is what we're going to measure at the end, okay? So again, you guys should be, at this point, taking the time to go back to this document, and you're going to type out what the independent variable is. So again, the independent variable is what the scientist is changing. So they are changing would it be the amount, the type, the quantity, whatever it would be. And then your dependent variable is what we're measuring at the end, okay? So I'll go back to that original slide that kind of gives us the setup. And perhaps that will help you to determine what is the independent variable, what is the scientist changing, what is the dependent variable, what are they looking to measure at the end, okay? So at this point, you can pause it and fill in your independent and dependent variable on that sheet. All right, and we are back. So let's go over our independent and dependent variables. We did control group, experimental group, la, la, la. Okay, so independent variable is the concentration of fertilizer given to plants, or you can say the amount of fertilizer. That's what's changing between each of those groups, the experimental groups. It's getting a medium, a small amount of fertilizer, or a large amount of fertilizer. The dependent variable is the height of the plants. That's how we're going to see how tall it grows. And actually, if we go back to this document, we can see that in the hypothesis, it kind of gives us what our independent and dependent variable is. After the if, it says, if I give orchids a small amount, a medium amount, and a large amount, okay, these three things are our experimental groups. And if you think to yourself, well, what's different about each one of these? It would be the amount of fertilizer, Okay, so that is going to be our independent variable. Amount of fertilizer. Okay, and then our dependent variable. After the then the blank amount of fertilizer will grow the tallest. Whatever is your dependent variable comes after the then. So your dependent variable will be the height of the orchid. Okay, there we go. So we have so far a hypothesis, our experimental groups, control groups, independent variable, dependent variable. Now we need to come up with constants. So let's go back to our presentation. Ta-da, constants. Okay, so for constants, remember that they are things that have to be kept the same between the experimental group and the control group. So pretty much throughout all of our groups, they need to be the exact same. So if we are thinking about things that have to be kept the same, okay, for example, if we change these things, it would mess up our experiment and we wouldn't have a controlled experiment anymore. It would be just like we're changing more than one thing at a time, and I wouldn't know if it was the fertilizer or this that made the difference in the height. Okay, so think about a few constants. Come up with at least 2 right now. Type them up on your recording sheet, your practice problem sheet. You can pause it now. Okay, and we're back. So for our constants, basically, again, we said things that will remain the same between the experimental group and the control group. So some things that have to be the same because they would mess up our experiment if they weren't. That we may think, oh, maybe this is a cause of creating the difference in height. Instead of the amount of fertilizer, it could be the amount of water given each day. It could be that all plants are grown in planters of equal size. If I have a plant growing in like a little teeny, cup, like a 3-ounce cup versus in a huge planter, that could have an effect on the way that a plant grows. They're all grown at the same temperature. I can't have one in the freezer and expect it to grow really well. They all have to receive the same amount of light. Okay, I can't have one of them in the dark, but hey, man, they were given a lot of fertilizer. That's not going to help it to grow any. So again, constants are things that have to be kept the same because if they're not, you don't have a controlled experiment. So these are some examples of things that you could have put in that document, your practice problem. Okay, so the results, here we go. Ta-da, let's see what happened. Basically, group A, which only got water, grew to be 15 centimeters tall. Group B, which got weak fertilizer, grew to be 35 centimeters tall. Group C, which had a medium amount of fertilizer, grew to be 28 centimeters in height. And group D, which is the large amount of fertilizer, only grew to be 10 centimeters in height. So that's kind of interesting when we think about it. So after we gather our data, that would be the time to determine if our hypothesis was supported or if it was rejected. And again, these are the terms that we use to say, yes, my hypothesis or my guess was right, or no, I was wrong with my guess. So our hypothesis, if you said, and I figure most of you said medium, our hypothesis was rejected if you thought a medium amount of fertilizer would grow the best. The orchids given a medium concentration of fertilizer did not grow the best. Okay, so if we look back, it was actually the weak amount of fertilizer that grew best. So that's kind of surprising. And additionally, this is kind of our conclusions that we can draw, or kind of what does it all mean? We said that orchids grow best with a weak concentration of fertilizer, and actually a high concentration of fertilizer actually inhibits plant growth when compared to the control group. So what that means, this word inhibits, means it stops or prevents growth. So if we look at the chart, if you give the plants a lot of fertilizer, it only grew to 10 centimeters, whereas giving it nothing is only 15 centimeters. So technically giving a plant no fertilizer could be more beneficial than giving it a lot of fertilizer. It's kind of, too much of a good thing could be bad. So that was kind of an interesting comparison that we saw as well. All right, so after we draw our conclusions, we're pretty much done with the scientific method. We've gone through all of the steps. We've shared it. Lovely. So at this point, we have gone through our practice problem. You should have this entire document filled out. You should have at least 2 constants over here. That would be required as well. And then you're good for this document. Don't forget, too, that we also have an exit pass that's going to give you a little bit more practice. So basically, for our exit pass, what you're going to have is you're going to get a hypothesis. And then for each hypothesis that you get, you need to identify the independent variable, the dependent variable, the experimental group, and control group, just like you did over here. Okay, so you can use this document and the notes and the video to help you with the exit pass. So for example, for this one, says if hamsters are raised on a taco diet instead of a hamster chow diet, so like literally you give hamsters little tacos instead of, regular hamster food, then they will have less heart disease. Interesting hypothesis. So what you're going to do is for each of these, you're going to say, okay, the hamsters that eat hamster chow, would that be the independent variable, the dependent variable, the experimental group, or the control group? The hamster's diet, is that independent variable, dependent variable, experimental group, or control group? Okay. And then you'll go through each of these. Here's a hint. If it's talking about actual hamsters, because think about it, what are we doing this experiment on? Hamsters, people, plants. If it's giving you an actual group, okay, if it's the hamsters that, blah, 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 it's probably going to be an experimental group or control group. Okay, so that's my little hint to you. If it's actually saying a group of hamsters, is probably going to be again, experimental group or a control group. So for each of these, you'll go through, you'll read the hypothesis, and then you'll determine which of these little statements, if it's the independent variable, dependent variable, control group, experimental group, etc. Okay? And that is about that. So after today, we're going to be starting our new experiment, our last experiment of the year. And it's going to be using some of the scientific method to help us, okay? So you'll see that starting tomorrow. So again, remember, for today, you already watched the video because you're watching it now. You should have already finished this document because if you followed along with the video, you already filled it in. All you need to do now is the exit pass, and then you are done for today. So again, if you have any questions, you can always leave me a private comment, and I'll get back to you on that. But other than that, I hope you guys have a lovely day.